Hi everyone. Welcome back to CHM421 Analytical Chemistry. We will continue our learning on topic 5, gravimetric method or gravimetric analysis. In this topic, in this video, we will we will continue our lecture on the previous topics. So in this slide, it is particle size. So particle size of the precipitate can be classified into several groups. Like it can be ion, or it can be colloidal, or it can be crystalline. So these three types of particle size differentiate by the diameter of the particle. If it is iron, the diameter is about 10 to power minus 8 centimeters. Normally, iron dissolved in a solvent. So for the colloidal, it slightly bigger. So the diameter size is between 10 to power minus 7 to 10 to power minus 4. So the colloidal normally is remain suspended in the solution in very difficult to filter because it's suspended on the top of the solution. So crystalline, the size is bigger, more than diameter is more than the power of minus 4. So the crystalline normally is can be settled or can be precipitated spontaneously. So meaning that it's filterable. It can be filtered. So coagulation of colloid. Colloid, as I mentioned just now, is the diameter of 10 to the power minus 7 to 10 to the power minus 4 centimeter in terms of diameter. The coagulation of colloidal is the process with the colloidal particle lumped together. So the colloidal particle will form larger particle. So during the coagulation, the colloidal particle will be lumped together to form the larger particle. Okay, so several approach for coagulation of colloidal. The heating the colloid while stirring, so it can reduce the size of counter ion layer, making it easier to the particle to approach to each other. So remember coagulation, we lump together the colloidal particle into the larger particle. So when we heat the colloid while stirring, it can reduce the size of counter ion layer, so making the colloidal particles to approach to each other. Or we can increasing the electrolyte concentration of the solution. Unrelated non-ionic compound solution added into the solution to reduce the counter ion charge that will neutralize the particle. When the particle neutralized, meaning that the particle is not repel each other, so the colloidal particles tend to lump together to form a large particle. It can be done by increasing the electrolyte concentration of the solution. crystalline precipitate. Crystalline precipitate is the diameter of 10 to the power minus 4 centimeter. This type of precipitate is much easier to work with. The best approach is to slowly form the precipitate using warm and dilute solution. Allow it to digest without stirring. So crystalline precipitate is easier to precipitate out. So the size of particle depending on the following four factors. First is solubility of precipitate, the temperature, concentration of reactant, and the rate at which reactant mix. Four factors will affect the size of particle. As I mentioned, size of particle, it can be ion, it can be colloid, or it can be crystalline. So it's depending on the solubility of the precipitate, the temperature, concentration of the reactant, rate at which reactants mix. Okay. So this relative supersaturation is no need to cover, but if you would like to rate, you can do so. The relative supersaturation (RS), it's the it's the formula to control the particle size. Okay, for example, if you want to larger particle, we have to lower the relative supersaturation, the RS. So you can read this slide if you wish. Okay, moving on the next slide. The next slide is example of final year exams questions. This question is out many times, asked many times during the exam, October 2010, April 2008, or October 2007. So it asking you about state the principle of gravimetric analysis. If you still remember on the first video on the gravimetric method, I'm talking about the step for successful gravimetric analysis or gravimetric method. First, you have to identify the insoluble form of analyte, and then you have to separate or filter it, and then after you separate using the filtration, you have to wash to remove the impurities, and then you have to dry. After you dry, you have to convert it into the known composition of analyte by applying the heating. Okay, after that, lastly, you weigh using the analytical balance. So the four principles of gravimetric analysis. First, the analyte have to be converted into insoluble precipitate. Precipitate form, the insoluble form should be filtered and then washed to remove the impurities. And then we have to convert the product to the known composition by suitable heat treatment. Okay. Last, we weigh the mass of analyte is determined by subtracting the known mass of crucible. Okay, because we heat the known composition by using the crucible. So the crucible, it should be weighed before and after uh, the heat treatment. So this is another example of question. Is also a final year exams question. Is asking you to list the advantage of gravimetric analysis compared to trimetric analysis. There are lists of a few advantage of gravimetric, so you can pick up a few of them. So gravimetric is accurate and precise method because it's using analytical balance is to measure the miss of analyte. Possible source of error can be checked. Filtrates can be checked for reaction completeness and also inexpensive apparatus except for the furnace. Furnace we use it using the during the heating to convert the insoluble precipitate to the non-composition. Okay, other than these advantages, you can list using the advantages of gravimetric analysis. As I mentioned before, no standardization. What else? No calibration. So you can check on the next video. All right. So now we focus on the contaminant of precipitate. Co-precipitation is a process in which normally soluble compounds are carried out of solution by precipitate. Co-precipitation of other ion occurs during the formation of the targeted analyte precipitation. So meaning that during we precipitate the analyte, it can form another type of, it can be precipitate another ion. So it is co-precipitation. So post-precipitation of other ion. So other ion is the contaminant of the precipitate. So it can be co-precipitate or it can be post-precipitation. So this type of contamination post precipitation is occur after the formation of precipitate. So co-precipitation, the precipitate of other ion occur during the formation, but post precipitation, the precipitation of other ions occur after the formation of precipitate. So make sure you understand what is the difference between co-precipitation and post-precipitation. So this one, these two things is discussing about the contaminant of the precipitate. Contaminant meaning that the precipitation of other ion instead of analyte that we want to determine in the sample. Okay, so types of co-precipitation. Co-precipitation, the precipitation of other ion during during the formation of targeted analyte precipitation. So it can be divided into several types. It first is mixed crystal formation. Mixed crystal formation inclusion. Okay. So foreign ion or other ion present during the precipitation may be incorporated into the crystal structure of the particles, precipitate particle throughout the growth. So this, for example, this is the crystal structure of the analyte of precipitate, but the foreign ion also incorporated into its crystal structure. So we call it inclusion. Usually, uh, it happens when they are present of same charge ion. Same charge ion which the size differ less than 5% and belong to the same crystal structure. So this is the condition. So the inclusion can be happen if the charge of the foreign ion or the charge of the analyte precipitate has similar charge ion. The size also almost similar, less than 5% different, and it has a similar uh, crystal structure of this class of crystal structure. So determination of sulfate, for example, determination of sulfate in solution is barium sulfate. The presence of Pb, lead, and strontium Sr will cause the mixed crystal, can cause the inclusion happen, can cause the mixed crystal. So it can be PbSO4 or it can be SrSO4. So the problem solving, we use the selective precipitating agent to remove or to mask the other ion, or reprecipitation. The filter precipitates its dissolved and precipitate second time. Okay, other contaminant, other type of co-precipitation. Co is the precipitation of other ions during, so it's surface absorption. Co-precipitation is the surface of the precipitate, meaning that the precipitation of other ion or the foreign ion occur in the surface of precipitate. It is common cause of co-precipitation. The impurity is found on the surface of the precipitate, and it occur especially with gelatinous precipitate. Normally, surface absorption occur for the gelatin-like precipitate. Effect of surface absorption is before carrying down on otherwise soluble compound is the surface contaminant. Problem solving. So since the contaminant is on the surface of the precipitate, we can wash. So it can may help, but it's not much. So the attraction of counter ion or the foreign ion is too strong. So the foreign on the surface of precipitate, normally the binding is is too strong. So when we wash, it's not much. So so it can only get a limited exchange. So washing with volatile electrolyte. Uh, it is better approach since washing with volatile electrolyte is a better approach since the excess can be removed during the drying. So or another way, we do the reprecipitation. Okay, we have inclusion, mixed vertical, mixed crystal formation, inclusion, and also mixed crystal inclusion, and also we can have occlusion. Occlusion meaning that the foreign ion trapped within the pocket formed during the repeat crystal. Okay, so how to solve this problem? We do the digestion, the process in which waiting time to achieve desired outcome. The solubility precipitation is the dynamic equilibrium. Digestion can ensure the occluded material is eventually to the supernatant solution. So occlusion, the foreign ion trapped within the pocket form. So within the pocket form during the repeat root crystal. So for example, when we do the repeat precipitation, the counter ion will trap in the pocket of the crystal group. Okay, lastly is the mechanical entrapment. Mechanical entrapment, it can be occur when the crystal lie close together during the growth. So let's say this is the crystal growth and this is another crystal growth. So the repeat growth will trap a pocket of solution while the solvent can be removed. The trap ion will be remain after the drying. So when this crystal growth, the foreign ion, this one will be trapped. So it remain after drying. So how to solve this mechanical entrapment? We can do the digestion. So you this schematic diagram differentiate the formation of inclusion, the mixed crystal, occlusion, and also the surface absorption. This is the surface absorption. This is the occlusion. This is the inclusion, the mix of the mixed crystal. Okay. All right. Now is on the filtration. So remember, filtration is one the step in the gravimetric analysis. After the precipitation has taken place, the precipitate must be separated from the supernatant solution. So normally the supernatant contain excess common ion and other constituent. So filtration, of course, is using a filter paper to collect all the precipitate form. So we can have various grades of filtered paper. It's depending on the purpose. If want to filter the fine precipitate, very fine, so we will use grade filter paper grade number 42. For the precipitate look like gelatin, we use filtered paper 41. For the medium size or the crystalline size of precipitate, we use filter paper of 40. So filter paper number 40 for the medium size or the crystalline precipitate. Gelatinous like precipitate using 41. 42, it should be very fine of particle. We use a filter paper number of 42. All right. So after filtration, of course, the precipitate that we obtain using the filter paper, we have to wash. So washing is required because precipitating reagent usually we added in excess. In order to precipitate, we add excess amount of precipitating agent or selective agent. So since the precipitate form is usually not 100% insoluble, therefore we have to take care, great care should be taken during washing because we don't want the analyte flush out, so we not wash the precipitate too long. So the best way is to wash the precipitate only a few times, not to wash once the total, not to wash once with the total same volume of washing solution. Better we wash it portion by portion. For example, if you want to wash a 30 ml of washing solution, so we divide it into 10, into 3, 10 ml, 10 ml, 10 ml each. So it's better technique for washing. So comparison of washing technique. So in this example, as you can read, the precipitate form of analyte contain 1 gram of contaminant. So the precipitate form after filtration contain 1 gram of contaminant. Suppose after washing the precipitate using 50 ml of washing solution, the precipitate will hold 1 ml of washing solution. So meaning that after we wash the precipitate using 50 ml of washing solution, the precipitate can hold 1 ml of it. So compare how much contaminant remain in the precipitate after we one washing using 50 ml one shot, or we use 5 times 10 ml each washing. So we have two methods. Method number one, we wash with 50 ml of washing solution one shot. So amount of contaminant remain in the precipitate is 1 over 50 because 1 ml is of the washing solution. So washing is 50. So 150 times 1 gram is contaminant. So 1 over 50, 1 over 50 times 1 gram. So 0.0 0.02 gram. So, however, if we use second technique, 10 ml for 5 times, so the amount of contaminant will become lesser and lesser. So, because 1 ml for each 10 ml times 1 gram, so the first one is 0.1 gram, and then if we wash out again, so 1 over 110 times 0.1, so okay, so the third one, 1 over 10, 0.01, we can sorry, third, it remain 0.001, fourth will be remain 0.0001, fifth will be remain 0.00001. Okay, you can try 1 over 10 times 0.001, so you can obtain this. 1 over 10 times 0.01, you can obtain this. 1 over 10 times 0.0001, you can obtain this. So meaning that the amount of contaminant will be lesser if we wash it using method 2. Okay, the total volume of washing solution we divided into small portion. Okay, so ideal washing liquid, the liquid can be used as a washing solution. Supposedly, it's no the solvent is no action or no reaction with the precipitate. The solvent that we wash is the washing solution. It should dissolve the impurities easily. So the liquid solution, washing solution also should be easily evaporate when we drying the temperature of precipitate while we heating the precipitate. So the washing solution should be easily to evaporate, and it contains no substance that will interfere the determination of the analyte of the sample. In general, we just use water is the washing solution. Okay. After washing, of course, we have to drying to get dry sample, and then we have to ignite the dried precipitate in order to convert into the non-composition. So after filtering, the gravimetric precipitate is heated until the weight become constant. Heating can remove the solvent, the washing solvent, or the solvent that used. Any volatile species carried out down with the precipitate. Some precipitate must be ignited to decompose the solid and form a stable form of non-composition. This new compound we call it precipitate form. Okay, so the precipitate form after drying in ignition, the precipitate before undergoing precipitate form. Precipitate form is the precipitate before undergo drying in igniting. So before we applying the drying in ignition treatment, so it is a precipitate form. So the precipitate weight, the precipitate is converted after drying in ignition. So we call it precipitate weight. Precipitate weight. The precipitate is converted to more stable form of weighing. So two methods are to calculate the amount of analyte in the precipitate form, either chemical factor or gravimetric factor. So we will explain further these two methods to calculate the amount of analyte in the precipitate form, either using chemical factor or gravimetric factor on the next video. All right. Okay. See you again on the next video. Okay. Bye bye.